Here are some key points and properties on parabolas. First of all, parabolas can either open up or they can open down. A parabola that opens down would have both ends facing down. A parabola always has a domain of all real numbers, and its range will vary. Here the range would be y is greater than or equal to -4 because this is the minimum value. The parabola has a vertex, which is the maximum or the minimum point. Here the vertex is -1, -4. Parabolas have a line of symmetry, which passes directly through the vertex. Here the line of symmetry, also called the axis of symmetry, has the equation x equals -1. The line of symmetry is not the number -1, it is the line x equals -1, which is the line which passes through all values where x equals -1. Parabolas have roots, which are where it crosses the x-axis. Here the roots are 1, 0 and -3, 0. A parabola can have 2 roots here, or it could have 0 roots, or it could have exactly 1 root. Parabolas also have where they pass through the y-axis, the vertical intercept. So here is the vertical intercept. The vertical intercept of this parabola is it is 0, -3. The line of symmetry is important because it reflects all points. They're all equidistant on a horizontal line from the line of symmetry. For example, this root is 2 away from the line of symmetry, and the other root is also 2 away. This point here is 1, 2, 3 away from the line of symmetry, and this point 1, 2, 3 as well. Hello everybody. Today and Wednesday, we're going to be taking a look at reviewing all the concepts we have learned this far in the class in preparation for our Unit 1 test next week. So let's take a look at transformations first. What are all the different transformations we've learned about so far? We've learned about reflections. We've learned about stretches and shrinks. We've learned about horizontal translations, and we've learned about vertical translations. So let's just very quickly see how we would see each of these different transformations in comparison to f of x equals x squared. Let's start with 1, reflections. We will know there is a reflection over the x-axis when you have something like g of x is equal to our initial function, but it's a negative version of it, so negative f of x. If you want to see why that's a transformation, this would equal, if I substitute x squared for f of x, I will get negative x squared. So this minus sign here is what is determining whether there is a reflection. 2, stretches and shrinks. Say I have h of x is equal to a times f of x. This will give me a stretch or a shrink because this will equal a times x squared. If a is greater than 1, it is a stretch. If a is less than 1, there is a shrink. And to be precise, I'm going to say the absolute value of these, because if there is a flip or a reflection, we don't want to talk about -100 being a shrink when that would still be a stretch. So remember, you have to tell me exactly what the quantity of the stretch or shrink is. So in this case, the stretch or shrink would be a. So we wouldn't just say there is a stretch, we would say there is a stretch of a. Okay, let's take a look at 3 horizontal translations. This would be if you had p of x is equal to f of x minus q, which would equal x minus q squared. This would give you a horizontal translation of 2. Of q, rather. So it's happening inside the parentheses, and it goes the opposite direction as the sign. So here we're subtracting q, so it's going to go q to the right. If it was x plus q, it would go q to the left. And finally, we have vertical translations. Let's say we have m of x is equal to f of x plus k. This will give us a vertical translation of k. Let's do an example problem. Here we have q of x equals negative 3 times x minus 2 squared plus 6, and we want to compare it to our function f of x equals x squared. So basically, I want us to list all of the different transformations. Here, because there is a negative sign right here, that means there is a reflection, and we're going to say across the x-axis, because if I just said reflection, then it could have been across the y-axis, but it's off across the x-axis. And now we see there, because of this 3 here, there is a vertical stretch, and it is of 3. That's very important. We always have to make sure that we're telling our audience what the vertical stretch or shrink is of. Next, there is a horizontal translation of 2, because we are subtracting 2 here. And finally, there is a vertical translation of 6, because of this 6 here. If I want to find the equation of this blue parabola using transformations, the way I'm going to do this is first I'm going to identify the horizontal and vertical translations that have occurred. It has been moved over 3 to the left, and it's been moved over 2, moved up 2. So this tells me there is a h translation of negative 3, because it's been moved 3 to the left, and a vertical translation of 2. Now I need to figure out if there's stretches or shrinks, or if there's flips. There's no flips because it is opening up. It's going up on both sides. And there's let's see if there's a vertical stretch or shrink. Well, let's look at this red parabola first, which is our basic one. So this x squared could also be written as f of x equals 1 times x squared. So it doesn't have a vertical stretch or shrink. So when I go over 1 from the vertex, I go up 1. Let's compare that to this blue parabola. When I go over 1 from the vertex, I go up 2, which tells me there is a vertical stretch of 2. This would finally, all of this, it's going to give me the equation y equals 2 times x minus negative 3 squared plus 2, which will simplify to y equals 2 times x plus 3 squared plus 2. The vertex form of a parabola is y equals a times x minus h squared plus k, where hk is the vertex. Here a is the vertical stretch or shrink. If we wanted to create an equation for this parabola in vertex form, what we would do is we would need to find the vertex. Here the vertex is the point negative 1, negative 2 vertex. Because hk is the vertex, this tells me h equals negative 1 and k equals negative 2. I'm going to write that over here. K equals negative 2, which tells me our equation will look like y equals a times x minus negative 1 squared minus 2, which will become y equals a times x plus 1 squared minus 2. Now all I need to do is figure out a. Does this, which is the vertical stretch or shrink, so does this graph have a stretch or shrink? Well, when I go over 1, I go up 1. So that tells me there is a vertical stretch of 2. So a is equal to 2. So that gives me an equation y equals 2 times x plus 1 squared minus 2. The intercept form of a parabola is f of x equals a times x minus p times x minus q, where p0 and q0 are roots and a is the vertical stretch or shrink. If we have this parabola here, we see that its roots are at the points 2, 0 and the point -1, 0. These are the roots. This tells me, I'm going to write them here, -1, 0 and 2, 0 are roots. This tells me that p equals -1 and q equals 2. It could be the other way around. I've just chosen to write it like that. If I plug these into my equation, I'll get f of x is equal to a times x minus -1 times x minus 2, which will simplify to f of x equals a times x plus 2 times, x plus 1 times x minus 2. Now I need to figure out a, which is the vertical stretch or shrink. Here it's a little bit hard to tell, so I'm going to do algebra instead. So I see there's this point 0, -4 here, which is a really easy point to plug in, so I'm going to plug that into here. This basically says that f of 0 equals -4, so plugging that into my equation, I get -4 is equal to a times 0 plus 1 times 0 minus 2, which will give me -4 equals a times 1 times -2. So if -4 equals -2a, then if I multiply each side by -1/2, this will give me a is equal to 2. So I can write my final answer as f of x equals 2 times x plus 1 times x minus 2.